Assalamu alaikum warahmatullah. Now we move on to discuss subspaces. Here, subspaces are special kind of vector spaces that contain the origin, and of course they are closed under additional multiplication. Okay, and of course they inherit all the properties of the vector space. Of course, okay. So they must be closed under addition and multiplication, as we said, and those are given points A and B. Example of subspaces are the solution of the homogeneous equation Ax equals 0. So now if A is full rank, A is full rank is full rank, so the solution here x is the all zero vector only, which is very trivial. If A is not full rank, it's rank deficient, so x is a set other than the all zero vector, so it contains all zero vector, so it will satisfy this condition, and it has many other vectors as well, so it is a subspace. As for solution of the inhomogeneous equation, unless b equals 0, it's not a subspace. So let's take a few examples here. Okay, so in these figures, let's discuss them here. So okay, now here this region A or set A is not a subspace. Why? Why A is not a subspace? Because let's say that we take a vector here. Okay, this vector, call it x. Multiply x by lambda. Lambda is 10, so it becomes here. So let's say this y. So obviously y does not belong to A, hence it's not closed under scalar multiplication, so it's not a subspace or a vector space in the first place, right? If we look at B, so any point in B, if you add any other point to it, it will still remain on the same set, and if you multiply it, so x, so let's say this is x and this is y, x plus y still in B, lambda times x is still in B, right? So it is a vector space, but not a subspace because it does not contain the origin. Okay, so if you look at this one, this is C, I think this is C, yeah, it contains the origin, so it's good now, but is it a subspace? No. Or even a space, vector space? No. So let's take this is x, right, and this is y. X plus y will give you this point, and this point does not belong to C, so it's not a vector space in the first place. Okay, so it will not be subspace, of course. D is just a single value, so D is just this all zero vector. So of course, if you add 0 with 0, it will give you 0, multiplied by anything it will give you 0, and it contains 0, so it is a subspace. Okay, let's take a more evolved example. Okay, let's take the half space. So this is x and y, right? So let's take this. So let's call it subset A. And what is A? it's so let's define A here, right? So A is the set of x and y. So x can take any values, but y such that y is greater or equal 0, right? X can take anything. So if you don't specify x, you say that x um, belongs to R. So if you want to specify it, right? So okay, let's specify it. X belongs to R, right? Yeah. This is set A. Is set A a vector space? So let's check the closure under multiplication and addition. Let's take addition, right? So let's say that we have two vectors A and B that belong to A. So let's say now we have vector C equals A plus B. Does this vector belong to A? So let's change the color now, right? So we have vector A here and let's say vector C here, right? So any vector will give you this, right? So it belongs to A. Even if you take vector here and vector here, it will be on the same line, right? So we can say that it is closed under addition. How about multiplication? So we have lambda that belongs to R and A as well, as we said earlier, belong to the set A. Does the vector B equals lambda A, does it belong to A? No. Why? If lambda is negative, then B does not belong to A, right? Look at here. If this is lambda, this is A, lambda will become this vector here, right? Minus A. And this vector does not belong to A. So this is not a vector space. And of course, it's not a subspace, right? So you need to check the conditions that define the vector space in order to judge is this a vector space or not.